Stratasys ABS printed on Stratasys printer, Stratasys ABS printed on BambuLab printer, and BambuLab ABS printed on BambuLab printer. There is a huge difference in the price, but is there any bigger difference in the strength? I don't know, let's find out together. The whole idea for this video came when one of my viewers from the USA contacted me. Since 2013, they're using a Stratasys 250MC 3D printer, and they're using mostly with the Stratasys ABS P430 filament. This printer is broken now and it is no longer supported by Stratasys, so they move on. They bought Bambu Lab printers X1E. That's some kind of industrial version of X1C, which is discontinued by now, but they still have a lot of P430 cartridges. Yes, cartridges and not spools. I know I will be asked, so I try to collect here the information, the reason, purpose of the cartridge, material identification, usage tracking, environmental protection properly from the moisture, and I think the most important is locking the ecosystem. And since they cannot use them as they are with the Bambu Lab printers, they open it, re-spool it, and one of that spool is sent to me, so I can compare this industrial ABS to some regular consumer ABS, which is usually much cheaper. Now this testing wouldn't be fair, because this filament is designed to be in that cartridge. You just insert that cartridge into Stratasys 3D printer, and all settings are default, and you will get some theoretically very strong parts. I can print this only on Bambu Lab printer, so to have a better comparison, that's why I have a second group of the test objects. I found a company here in Budapest who offers Stratasys printer 3D printing using the Stratasys filaments. Only it will be M30, that's a newer ABS filament. But these test objects I ordered myself from this company. By the way, this video is not sponsored by any of these companies which I mentioned so far, but it is sponsored by Polymaker. Actually, the whole channel is sponsored by Polymaker. It is good that it is sponsored, because definitely I would be in a minus with the budget. For the tax fees for this filament from the USA, I paid $36. For these 3D printing services, Stratasys ABS on Stratasys printer, I paid $140, that's the price together with the shipping. Name of the company who printed these test objects for me is Varinex, and they offer 3D printing services in EU. Not only FDM Stratasys 3D printing, but also metal 3D printing, SLM, SLS, SLA, and since we are in the same city, they invited me so I can visit the manufacturing. And of course I accepted it. And definitely I was really amazed about these Stratasys industrial printers. Yes, I know I will get a comment that they're extremely expensive, but this is completely new category. Much bigger printers, the reliability is huge, and all settings are default. Very interesting, you just insert the cartridge and the printer recognizes the material. In the slicer, everything will be default. Interesting, during the printing, because I visited the printing of my test objects, I couldn't even see the print parameters. I can see only the print time. Now there is one thing I noticed here, that they are printing very slowly. When I was there, the printing was at 31% and the time was 4.5 hours. Total printing time will be 14 hours. For me, this was quite slow compared to the Bambu Lab printers, but as I mentioned, there will be a third group of the objects. That's the Bambu Lab ABS printed on Bambu Lab printer. And I will use completely different settings, and I think this will be printed in 1.5 or maybe 2 hours, but I will show you the slicer settings later. Just very quickly about these two companies. Stratasys, it is USA-Israel company. They are making very expensive industrial 3D printers and filaments. Bambu Lab, Chinese company with a modern, fast, good quality products and affordable price. Probably you are mostly familiar with Bambu Lab printers. Stratasys is very familiar in industrial range. Let's take a closer look of these objects printed on Stratasys printer. The quality is great, absolutely no warping, and these are printed in vertical position just to test the layer adhesion, and these overhangs came out great, Absolutely no issues with these test objects. And these two filaments will get some longer drying, and only after that I will start with the printing. With the Bambu Lab ABS, I will just use the default settings in the Bambu Studio. Now with this ABS Plus P430, I have to do some experimenting because I'm not sure what settings to use. Probably I will start with the generic ABS profile, but I think I will slow it down and maybe increase the temperature because probably the temperature inside the Stratasys printers is a little bit higher than default settings for generic ABS. Bambu Lab recommends the drying 80 degrees Celsius for 8 hours, and this setting I will use for both filaments. Objects will be printed with 2 walls and 100% infill. Bambu Lab ABS, let's see the default profile, 65 chamber temperature, 90 will be on the texture PI bed, 270 on the nozzle, 20 will be the maximal flow rate, and the part cooling between 10 and 60%. And let's see the printing time, it will be approximately 3.5 hours. The start is great. Last 2 vertical hooks. And it will be finished soon, without any problems. For next printing with Stratasys ABS, I need some experimenting, so I will print these test specimens by object. I will use 3 walls and 0% infill, and here you can see the parameters, but the most important is that I will vary the temperature from 260, then 270, and final 280 degrees Celsius, but later I will show you my final slicer settings. And our response, Stratasys ABS, starting on 260 degrees Celsius. Here you can see the finishing of the first object, and it's moving to the second one, and I'm changing the temperature manually. I can do this in the G-code directly, but for me this one is simpler now, only I have to be there when it's moving from one to second object. And as you can see, the temperature is changed only in few seconds. And this is moving to the third object, changing the temperature to 280 degrees Celsius. Last test object on 280 degrees Celsius, and even this last one looks great. And good news is that it didn't explode. Stratasys filament inside Bambu Lab printer. Quick check of the bed adhesion. Oh, I think I will increase the bed temperature. They are marked 260, 270 and 280 degrees Celsius. The improvement is obvious, but the improvement between 260 and 270 is bigger compared to 270 and 280, and all test objects are reprint on 280 degrees Celsius. And now let's see my final settings: 65 chamber temperature, 150 in the bed, 280 will be on the nozzle, and only 8 the maximum flow rate, and the part cooling between 0 and 40%. And the printing time will be a little bit more than 4 hours. I have to leave the home now, but I believe that this printing will be fine too. The bed is 60 degrees Celsius and it's completely movable now. Let's measure the shrinking, and on this one printed on Stratasys I cannot even feel the elephant foot. 80.05, so no shrinking. Maybe it is compensated in a slicer, I'm not sure. This is a Stratasys P430 printed on Bambu Lab. 79.54, so there is a shrinking. A little bit bigger than for the average ABS, and this is Bambu Lab ABS, and similar shrinking, 79.54. The design length is 80 mm. Quick weight check. 33 grams. 35, a little bit heavier, interesting, and the Bambu Lab 34, so they are close. And why are they connected? Well, not only because of the stability, But with this I'm sure that it will be printed in vertical position. I have some bad experience with Chinese services when they find out that if it is single, then it is better if it is printed in horizontal position. I will start the testing with these hooks on my DIY testing equipment. It is less accurate, but I like it because immediately we can see the break and the measured value. M30 ABS, P430, Bambu Lab ABS. And for the moment I will show you the break cross-section. It is very similar in all three cases. It is very important to remember these markings. SS means Stratasys ABS-M30, printed on Stratasys 3D printer. SB means Stratasys ABS Plus P430, printed on Bambu Lab H2D. And BB means Bambu Lab ABS, printed on Bambu Lab printer. And this hook is printed in vertical position, and it must resist to the bending and tensile strength. Now that the tensile strength is along the z-axis, so it is actually the layer adhesion, and we can see the Bambu Lab is weakest in this case, and the two Stratasys ABS are the strongest, but still small advantage with the P430. And now the S hook, which is printed in horizontal position. Side by side three materials. And again here you can see the cross section. With the Bambu Lab it is a little bit different break type. This hook is printed in horizontal position, so again we have here the bending and tensile strength, and we can see that the strongest is P430, weakest is the Bambu Lab, and the M30 is somewhere between. For next few measurings I will use my machines. On this one I can do the bending and tensile test, and here the impact test, the IZOD and Charpy standards. 3-point bending test, speed up 4 times. Based on ISO 178. Here you can see the graph load in the function of time or deformation. And now you can see the maximum load, bending strength and elastic modulus. The bending strength is calculated from the maximal load, so that's why only this one is presented on the graph, because the ratio is the same. And we can see the strongest here is the P430, the other two are very similar and a little bit weaker. Elastic modulus, it depends also from the deformation, and in this case again the P430 is the strongest, and the weakest is M30. Tensile test. These objects are printed in horizontal position. Maximal load in newtons, 3 measurings, but later I will show you on the graph. This is for P430 and for the Bambu Lab ABS. One more time I want to mention that these objects are printed with 2 walls and 100% infill, not maximal number of the walls as usual. And next to the newtons I also calculated the values in kilograms, because usually in earlier videos I use this unit. And if you watch the pure tensile test, the SB or P430 ABS Plus is the strongest, and M30 is the weakest. Bambu Lab somewhere between. Layer adhesion test. These objects are printed in vertical position. M30 ABS, the maximum load in newtons, the second filament, and the Bambu Lab filament. Pure layer adhesion or strength along the z-axis. This is the value in newtons, but I also calculated values in kilograms, because I have my rating table, and according to this, the SS is acceptable, BB is good, and SB or P430 has a great layer adhesion. Impact test. IZOD standard. No complete break with the bamboo test objects. All results a little bit chaotic, but don't worry, I will show you later everything in a table. Charpy standard. And again all 9 results.
These two are different types of the tests, so the numbers are not really comparable to each other, but always get very similar values. And we can see that in this case the Bambu Lab ABS is the toughest and the most brittle is M30. And the P430 is somewhere between. And now the elimination hook test. Earlier I got a comment that this test is not really necessary. I know it's not, but it's fun. The weakest always fall out. Only problem is that sometimes they fly away a lot and it's hard to find the pieces. I have this acrylic pipe, but so far I have to find a solution to extend the holder, maybe to use some chain. But so far I will try as it is now. In the first pulling, the M30 broke first. In the second one, the Bambu Lab. And now Bambu Lab fall out, so the winner is P430. Comparison temperature test in the oven. Objects are tilted so they will deform in the same direction. This oven thermometer is accurate, only it has some delay. But this test is the comparison to each other's. And the Bambu Lab deformed the first, immediately after the P430, and the most temperature resistant was M30. Creep test in the oven. The temperature stabilized on 50 degrees Celsius and I will use 1 kilogram load, not 1.25 which I usually do, and I will measure the deformation during this 1 hour. Sorry for the bad focus, and before the measuring, the object spent a little bit more than 1 minute in this 50 degrees Celsius. 1529, 1554, 1588. After 1 hour, let's measure them again. The temperature was stabilized, 50 degrees Celsius. This is their deformation after 1 hour. It is hard to present the measuring inside the oven. They are all measured, let's remove the load. The permanent deformation is very similar, but the smallest on M30 and biggest on Bambu Lab ABS. With blue we can see the initial deformation, distance between two reference surfaces, but even this was measured approximately after 1 minute. After it was exposed to this 50 degrees Celsius. And with the orange we can see the deformation after 1 hour. And the difference between two is calculated in percentage and presented on the right side. And we can see too, Stratasys ABS filament has very similar creeping, but with the Bambu Lab we can see a little bit bigger, at least on this 50 degrees Celsius.
While watching only the numbers, looks like the P430, which was printed on Bambu Lab, is the strongest in the most cases. But this was the only filament which was not printed on default settings, because usually these kind of settings are designed so any kind of the object is printable with them, but here I could go out from that comfort zone and I could increase the temperatures, for example, because only my test objects has to be printed with it. About the other two, Stratasys M30 and Bambu Lab ABS. More or less they are very similar, sometimes one was the better, sometimes the other. For example, on impact test, the Bambu Lab ABS was the strongest, the toughest material. M30 is the most heat-resistant filament between these three. And now the question, why would anybody use expensive Stratasys ABS-M printer if mechanical properties are more or less similar? Well, what I could collect, for example, the most important I think is reliability and the print quality. Only from these few test objects I could see big difference in the print quality. No elephant foot, no visible seams line with Stratasys printing, bridging overhangs came out much nicer, and we have much better dimensional accuracy. Maybe this accuracy shrinking is compensated in the slicer directly, I'm not sure. And another possible reason for better print quality is maybe the smaller layer height, because I printed my test objects with 0.2 millimeters, but I have the feeling that they use smaller layer height. This is the screenshot which I got, and not only the temperatures, but we cannot see the layer height too. I think it is more, this could explain why is that big difference in the print time. 14 hours versus 3.5 or 4 hours, that's big difference, but with the smaller layer height, that's actually normal. About printers, just one example, Stratasys industrial printer and quality. Until I was there, I had this conversation, and they mentioned I don't have to do any maintenance on these printers. Once a year, somebody from Stratasys will come here and do the maintenance, and that's it. On Bambu Lab, you will get the pop-up message that you have to do every 1 month, lubricate the X, Y axis, Z axis, and similar. Not a big deal. And is it worth maybe that price difference? Well, this is something what you have to decide. Probably most of you will think that this is still too expensive, but there are some industrial users who will think that this is worth the price difference. Okay, if you have some other experience with these two printers, most from maybe the Stratasys, then fill us down in the comment section. Huge thanks to the Polymaker for sponsoring my channel, but also to all my Patreon supporters, because definitely I would be in minus with the budget. I spent at least $200 for these printings, and I earn approximately $10 or $20 from YouTube ads. And one more reminder, if you like this kind of videos, don't forget to subscribe, and maybe you should enable that notification bell button too, because approximately I have 10,000 subscribers who enable that bell button, and basically this is the average number of the views. So 80% of my viewers are those who enable that notification button too. Thank you for watching this video until the end, and as always, happy printing!